All right, so we are going to cover topic 1.2 in this video, and then 1.3 will be a different video. So we'll get through the first half of these notes in this video, and then 1.3 will be an additional video um, separate from here. Stuff straight. Okay, so we're going to talk about average rates of change and linear and quadratic rates of change. So average rate of change is basically what 1.2 is. Okay, a lot of times that is abbreviated with AROC. That's how you'll see us write it several times. But rate of change is simply slope. It's something that you have already learned. You've already applied it in several different ways. It is just basically slope. Okay, so when we look through here, one thing that we want to consider when you're considering rates of change at a given point, it's helpful to think about the graph as a roller coaster. So if the car you're on is going up the roller coaster, then that is a positive rate of change. If the car is going down, then that is a negative rate of change. Okay, so if we look down here at the first example we have, okay, well, let's talk right here. First of all, so for instance, on that roller coaster, if you're at the very top or at the very bottom, okay, you're not moving up or down. And at that very single instant, you are changing between going up and going down or going down and going up. Your rate of change is zero. It's way easier to see that on a roller coaster when you're going up and you get to the very top and you kind of pause and then you fall down than it is to understand that when you get to the very bottom, it actually does the same thing. But if you think about it, if our slope is negative coming down, then negative, 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 negative. Before we can go positive, we have to go to zero. So there is it's a very small amount of time that you are technically neither down there before you go back up. Okay. So if we look at our figure here, you'll see that. Okay. So the rate of change of F at T1, so that's over here at T1. Okay. That is going to be, we're going up. So that is going to be positive. Okay. The rate of change of T2, straight across right there. So that is going to be zero. And the rate of change of T3, we're going down. So that is going to be negative. Okay. All right. So for example, number one, okay, we've got a graph over here. The figure shows function f in the xy plane with three labeled points, A, B, and C. So let's look at our slopes or our rates of change. So there's A, there's B, and there's C. All right. And they want us to order these from least to greatest. Well, one thing I know about A, it is a positive slope. B is a negative slope, and C is a zero slope. So if I order these from least, obviously the least is going to be the negative, and then zero would be next, and then A would be our positive, so that would be the greatest. Okay. All right, and then example number two. The figure shows the graph of a function on the xy plane and four label points. Of the following points, at which is the rate of change the least? So the rate of change the least. All right, so let's look again. Here we are positive. Here we are positive. Here we are negative. And here we are negative. Okay, so we can throw out A and B. Positives are obviously going to be greater than negatives. So which one is the smaller? So if you notice, it's going to be where it's steeper. Okay, because this might be like -3, and then this will be -5. So the least -5 is smaller than -3. So our answer is going to be D, but we don't just put D. We're going to justify that. At this point, the slope, or we're going to call it the rate of change, is the most negative. Okay. All right. So flipping over to the next page. Okay, we're going to start talking about, just in general, the formula for AROC. So first of all, again, like I said, say this a lot because it is very, very, very important. All right, your average rate of change between 2 points is simply the slope. But we aren't going to say slope. We're going to say average rate of change. Okay. So whenever we learned about average rate of change, we learned, or slope in general, you learn kind of y minus y over x minus x. That's what you learned. But the formula that we're going to use more so in class now is going to be f of b minus f of a over b minus a. Okay, these are still your y's. F of b is a y value, f of a is a y value, and b and a are your x values. Okay, so same thing as it works over here. Okay, so if you look right here, if this is point A or x value of A, then that would be f of A for that part. And if this is point x value of B, then this would be f of B. All right, so be careful that your outputs or your y's are always in your numerator. Okay. So let's calculate some average rates of change. All right, so you're going to notice, zoom in a little bit, okay, your intervals. So remember, these intervals are all x values. So this is your A and this is your B right here. Okay, so this will be your A and this will be your B. So we're going to use the formula from up here again, f of B minus f of A over B minus A. All right, so if I do that, my AROC for this problem would be f of negative 1 minus f of negative 2 over 1 minus negative 2. That's what it would be. Now, I'm going to come down here, and I don't do this for every problem, but I am going to make sure I do it to begin with so everybody's on the same page. All right, I'm going to go down here, and I'm going to calculate f of negative 1. So I'm going to plug in negative 1 into my function and evaluate that. So negative 1 cubed is negative 1. Hey, answer that, should I? Negative 1 cubed is negative 1 times a negative makes it a positive 1. This is negative 3, and 1 minus 3 would give me negative 2. All right, then we've got f of negative 2. So I'm going to do negative 2 cubed plus 3 times negative 2. So that would be negative 8. That makes a positive 8. 8 minus 6 is positive 2. So now I have the values that will go in up here. All right, so if I plug those values in, I'm going to have negative 2 minus 2 over 1. And that's going to give me negative 4 divided by 1, which makes my AROC negative 4 for this problem. Why can't I find my... Sorry. Trying to... Okay, sorry. Had somebody walk in here and had to pivot. Okay, all right, so A right here was negative 4. All right, so now let's go to letter B. Okay, so again, this is our A and our B. We're still using the same formula. Okay, so we're going to do, and I'm not going to write out all the work here this time. I'll just kind of talk through it. So our AROC would be f of 4 minus f of 1 over 4 minus 1. So if I plug in f of 4, so if I plug in 4 here, 4 plus 1 is 5, 4 plus 6 is 10, 5 over 10 is 1/2, minus 1 plus 1 is 2, 1 plus 6 is 7, so minus 2 over 7, and then 4 minus 1 is 3. Okay, we talked about simplifying this fraction in general. Okay, I don't care how you simplify it, but it does need to be simplified. I do 3-step cross multiplication. Some of y'all like to do common denominator. If you did common denominator, it would be 14. So that would be 7/14, and this would be 4/14. And 7 minus 4 is going to give me 3. So now I have 3/14 as my top number and 3 still on the bottom. And we're going to do the famous keep, change, flip. Now, while I record these, you can always slow it down, rewind it, go back, whatever you need to do to revisit it. I do talk to nobody in class a lot of times, so I do tend to go a little bit faster. All right, so that's going to be keep, change, flip. Oh, it's supposed to be 1/3, sorry. 3s will cancel, so now I'm left with 1/14. So our AROC here is 1/14. Okay. All right, same thing here. This is our A, this is our B. So our A rock, and we're using the G function this time. So it's going to be G of 3 minus G of negative 1 over 3 minus negative 1. All right, so we're looking at a graph. So G of 3 means I'm going to go to 3 on the graph, and I'm going to see where it intersects. And that's up there at 4. So that would be 4. G of negative 1 is right here, so that is 0. And 4 over 4 is 1. All right, so there we are algebraically and graphically. All right, down here real quick, the word per is a key indicator that you are dealing with a rate of change. Miles per gallon, students per classroom, online gamers per server. Okay, it also tells you the dependent or independent variable. The dependent variable is always listed first. Okay, so miles will be the dependent, students will be the dependent, and then gallon will be the independent. In other words, how many miles you can travel depends on how much gas is in your tank. Okay, that's what that means.
Good afternoon, everyone. I hope we all have had an amazing day.
TV timeout again.
Please listen up. We have some students who need to come to the main office for bus passes. So please stop moving.
All right. So down here, we want to find the average rate of change from 13 to 25. Okay. So if I do that, I'm only going to look at 13 and 25. So I'm going to find that calculation. So I'm going to say that our AROC is going to be F of 13, which is 30, or F of 25, sorry, which is 30, minus F of 13, which is 76, over 25 minus 13. And when I do that, that's going to give me negative 46 over 12. And that is at approximately negative 3.833. Now, since we had units in the problem, we want to put units in our answer. So remember, the Y's are on top, so it's going to be meters per second. Okay. All right, in AP Pre-Cal, make sure that we go 3 decimal places at least. You can go 4, but we at least want 3. Okay. All right, example number 6. All right, let's get up here to the top. Okay, positive rate of change indicates that as one quantity increases or decreases, the other quantity does the same. Because remember, we're doing slope or rate of change as a fraction. So if one increases and the other one increases, then that's positive. If they both decrease, so like I said, does the same, 2 negatives will still make a positive. So this is does the same. Okay, and then it's negative if one quantity increases, the other one decreases. All right, so we're going to look through example number 6, and it says, typically, is this a positive or a negative rate of change? So when I look at letter A, a child's age and a child's height. So typically, as the child's age goes up or increases, the child's height also increases, so that's going to be positive. A golfer's skill level and their score. As a golfer's skill level goes up, their score should go down, so those are opposites, so that would be negative. The height from the ground of a coin dropped and the speed of the coin. So as the coin is dropped, the height is getting less and less. So that is decreasing, but the speed should be increasing, making that also negative. And then the weight and the number of calories on a diet. So the more calories you consume, your weight should in fact go up. Those are the same, so that will be positive. All right, now, on this recording, I'm not going to pull up Desmos, but ultimately speaking, you could do this in Desmos. It does say calculator required. You would literally type this into Desmos, okay? And then you're just going to look over these intervals. So whenever I type this into Desmos, I believe it is just a parabola. I know that's not exactly correct on what it looks like, but ultimately it looks like this. Okay, I do know that the very highest point up here is that 2.47 value. Okay, I do know that this point over here is the 8.348 value, and I believe that this point over here is the negative I think that's the negative 0.66, but I'm not sure. I do know these two values are correct. Okay. But nonetheless, negative 10 would be way over here. So from negative 10 all the way to 8, it's saying that it is positive, but it's not because we are up and down. Okay. So that is both positive and negative. So it is not A. Same thing here. Positive from negative 0.633 all the way to 5 something, which will be over here. Okay. That is also, there's parts of each. So that is also incorrect. Negative from negative 10 to 2.4. Negative 10 to 2.4 would be down here to 2. So that is all positive. And then negative from 2.4 to 10. So 2.4 is where it would start here and it would go down. So that is in fact a negative rate of change, making it D. All right, so we're going to look at example number 8. The enrollment of a small private school between 92 and 2000 is given by the following table. Find the average rate of change from 92 to 2000. So we only care about those two values. Okay, so if I want to calculate that, it's going to be 164 minus 4 over 2000 minus 1992. That's going to give me 160 over 8, which is roughly 20 students per year. All right, describe it as increasing or decreasing for all of the data. So if you look here, we're going to have to calculate more than just that one. We're going to calculate each one. So the difference on this side is all 2s. The difference over here is 10, 26, 48, and 76. So 10 divided by 2, 26 divided by 2, so that would be 5, 13, 24, and 38. So our AROCs are all positive, therefore we can say that it is increasing. Do you think the data is linear? So linear would be a constant rate of change. These were not all the same, therefore if they are not all the same, it is not constant. So we're going to say no. Our AROC is not constant. All right, and then the last question about this, what do you think the concavity of the graph of this function would be? Well, if we are increasing, we would say that we are concave up. All right, so remember, and I talked about this in class, remember, obviously this is very important because we have covered it several times. If the AROC is increasing, the graph is concave up, and if the AROC is decreasing, the graph is concave down. All right, so we are going to finish up the next page, just the first part of this page up here, example 9 and 10, and I'll pick up topic 1.3 on a separate video. Okay. All right, so here we go. On what interval is the function concave up? We just talked about concave up is where it is increasing. So we are concave up from 1 to 2 right here, and from 4 to 5. And our reason when it says justify is the AROC of f of x is increasing. All right, concave down would be decreasing, so that's going to happen right there from 2 to 3. Points of inflection are where we change concavity. Well, changing concavity changes from increasing to decreasing. And that only happens right here at 2. Okay. And then last example, example number 10. All right, average rate of change from 0 to 4 is 18. So we've got our intervals 0 and 4, and we know is means equals 18. So if I do our regular AROC formula, so that would be h of 4 minus h of 0 over 4 minus 0. Okay, I would know that that would be h of 4. We don't know what that is, so I'm going to leave that as y. Minus h of 0 is 2 over 4 minus 0 is 4. And we know that is 18. So this is just a two-step equation here. Okay, we're going to do times 4. 4 times 18, so y minus 2 is going to equal 72. Then you move your 2 over, and y is going to equal 74. Okay? Also, just a reminder, AROC of a linear is constant. Okay? All right, so again, we'll pick up starting with 1.3 in a separate video.